Hello. Hello, students. Good evening, all. Hello, students. So, welcome to our next session of chapter complex numbers. So, we'll just have a quick overview of so far what and all concepts we have discussed in our particular chapter of complex numbers and what we are going to discuss in our today's session of complex numbers. Right. So I guess some of you has already joined. So meanwhile, remaining students join. We'll just have a quick overview of our previous sessions of complex number as well as our today's session of complex numbers. So the first one here is De Moivre's theorem. So as I mentioned, so for this De Moivre's theorem, we have seen the statement, and along with that, for each of the cases, we have seen the derivation. Right, so it's like for n, that is n positive integer, n negative integer, as well as when n is a fraction. Right, that will be our De Moivre's theorem, the statement along with the proofs and all we have discussed in detail. And along with that, we have done some questions also. So one question we have done here and one question I have given you for homework. So I hope you have done that question. So if you have doubts, you can ask me. Okay. So coming to our today's session. So as we have discussed our De Moivre's theorem, so today we will be starting with our application part of the De Moivre's theorem. Right, so what are these applications and all? So the application, the major part of application of De Moivre's theorem is nothing but cube root of unity. So that we are going to discuss here. So what is this cube root of unity and all? And we are going to trigger some questions related to the application part of the De Moivre's theorem. So this is our first topic, that is our session will be starting with the applications of the De Moivre's theorem. Right, so after the application of in this part, as I mentioned, we'll be covering the cube root of unity, and after that we are going to look into the nth root of unity. Right, so once we actually have a quick idea and quick detailed view in our cube root of unity, then it's easy for us to understand and do the thing of nth root of unity. Right, so for this nth root of unity, here we are having some properties. So you might have think that it will be like very easy, like it's not like much important and all, but here the properties of nth root of unity is very, very important. Right, so it's very, very important in our JEE mains point of view. So you have to be very careful while doing this nth root of unity as well as the properties of nth root of unity. Right, so then how we have our nth root of unity, in the same way we'll be having the nth root of complex number. So unity in the sense 1. So when we are taking with nth root of unity, so we can even take the nth root of complex number. So our complex number is nothing but z is equal to x plus iy. So for this, how we'll be having the nth root of complex number. So that we are going to discuss here. Right, and last concept for our today's thing, will be rotation of complex numbers, right? So like this rotation is one line, like how it will be rotated with respect to the other, so how it will be represented, and that and all we'll be looking into here. That is our rotation of complex numbers, right? So in overall, in majorly in our today's session, we are going to concentrate on this nth root of unity, like cube root of unity. So nth root of unity, nth root of complex number. So basically we are going to talk about nth root, right? So I hope remaining students are also joined for the session. So let's start with our first concept of today's session, that is application part of De Moivre's theorem, which is nothing but the cube roots of unity. Right. So basically, what is this cube root of unity? So for that, first here we are going to consider, okay, Ridhishri, good evening. So first here we are going to consider x is equal to 1 power 1 by 3. So what is this power 1 by 3 represents? So whenever we are having some variable is equal to power 1 by 3, if we square it on both sides, then what it will happen? It will become x cube is equal to 1, which means that particular equation will be having how many roots here? 3 roots. That means whatever we are having in the powers denominator, so those number of roots we are going to have for that particular equation, or for that particular expression, right? So here, as I mentioned, I have started by considering x is equal to 1 power 1 by 3. So by looking at the denominator, we are clear and cut with that. Here we are having 3 roots. So let's try and find out what are those roots here, right? So how we will be finding the roots here? So for that we will be having an equation. So now what I am going to do, I am cubing it on both sides, because I have to eliminate my fraction. So in my fraction, I am having 3 in my denominator. So I have to eliminate that. So to eliminate that, what I am going to do here, cubing on both sides. Then it will become x cube is equal to 1. Right. So to construct in the form of equation, this can be rewritten as x cube minus 1 is equal to 0. Right. So if you observe, this is in the identity form, that is x cube minus 1 cube is equal to 0, which means it is in our form of identity, that is a cube minus b cube. So if we are having a cube minus b cube, what is the expansion of it? That is a minus b. So here x minus 1 into a square plus b square plus ab. So a square means x square plus b square 1 plus ab. So 1 into x. This will be equal to 0. So simply what I have done here, I simply applied my identity a cube minus b cube, and then I expanded here, that is my a cube minus b cube. So this can be written as a minus b into a square plus ab plus b square. So the same thing I have done. So after factorizing this one, I end up having here x minus 1 into x square plus 1 plus x. So we can directly predict that I can have x minus 1 equal to 0. And the second one is x square plus x plus 1 is equal to 0. So from here I can directly say one of my x value is equal to 1, which means one of the solution of this cubic equation here is nothing but x equal to 1. So the other two solutions, what are those? So here we are having a quadratic equation. So let's try and simplify this quadratic equation so that we end up having our another two solutions of this cubic equation. So let's simply follow our format. So minus b plus or minus b square. So 1 minus 4a and c. So root over by 2a, that means 2. So here I'll be having my one solution is x equal to 1 and the other is x is equal to minus 1 plus I root 3 by 2, and the other one is minus 1 minus I root 3 by 2. So here these 3 roots are nothing but my cube roots of unity. Right. So this is my cubic equation, that is unit here. So this is my cube root of unity. After converting that into my equation format, if I end up solving this equation, it's actually a cubic equation. So I end up having 3 roots here. Those are nothing but cube roots of unity, that is x equal to 1 and the other is minus 1 plus root 3 I by 2 and minus 1 minus I root 3 by 2. Right. So instead of representing this to be a huge number, because it's a huge complex number, right? So minus 1 by 2 plus I root 3 by 2. So it's like a huge. So instead of that, what I'll represent this another root here by omega. So here I'll be using the symbol of omega to represent my solution, that is root of this particular cubic equation. Right, so what will be my roots here? That means 1, and instead of writing minus 1 I root 3 by 2, I am going to represent that with the symbol omega, and the other one minus 1 minus I root 3 by 2, this is represented by omega square. So now what are my roots for this cubic equation? So they are nothing but 1, omega and omega square. So you might have a doubt like why we are representing this by omega square. So this is actually our root omega. If we square this, we end up having our another root. So let's give it a try here. So let me erase this part. So I am having x is equal to 1 and the other is x equal to minus 1 plus I root 3 by 2, which I will be representing with omega, and the other one is x is equal to minus 1 minus I root 3 by 2, which I am going to represent with omega square. Right, so this omega, if we square it, we will be having our another root. So that is nothing but, let's give it a try. If you want, you can check it. So minus 1 plus I root 3 whole square by 2 whole square. So it's a complete square, right? So it will be a square plus b square, in the sense it will be 3i square and minus 2i root 3 by 4 here. Right, so here it will become 1 minus 3 minus 2i root 3 by 4, and 1 minus 3 is nothing but minus 2. So minus 2 minus 2i root 3 by 4. So I can take 2 common in the numerator and I can cancel it. Then it will become minus 1 minus I root 3 by 2. Right. So if you So let's get into the properties related to the cube roots of unity here. So the first property we are having here is omega cube equal to 1. So what are our cube roots of unity? So which are nothing but 1, omega and omega square. So these three are nothing but my cube roots of unity, where my omega value is nothing but equal to minus 1 plus I root 3 by 2. Right, so this is my omega value, and here 1 omega and omega square. So these three are nothing but my cube roots of unity. Right, so let's see the properties which are related to my cube roots of unity here. So the first property here is omega cube is equal to 1. So if you want, you can check it by solving it, because you already know the omega value. So if you do the omega cube, it will be equal to 1 here. Right. So omega cube value is equal to 1. And the second property is sum of our roots here will be equal to 0. That is 1 plus omega square. So sum of these three roots, 1 plus omega square, is equal to 0. Right, and the third property of our cube roots of unity is nothing but our omega square can be written as 1 by omega. Right, so why we actually require these properties of our cube roots of unity? Right, because these will be helpful for us while solving the questions. Right, so if for example there will be a huge equation and you have to find the value of it, then you can easily solve this by applying these roots, like these properties of cube roots of unity. Right, so the first property here is always omega cube will be equal to 1, and always the sum of the roots, that is our sum of the cube roots of unity, 1 plus omega square, will also be equal to 0, and our omega square can be written as 1 by omega, and when we have omega square equal to 1 by omega, you can even write omega will be equal to 1 by omega square. So vice versa, you can represent these properties in your questions while solving them. Right. So let's see some examples here. So what will be the cube root of 8? Right. So here we are having x is equal to 8. So how can we write 8 here? So 8 can be written as 2 cube. Right. So 2 cube is nothing but 8. So now this 2 cube, this can be written as x is equal to 1 into 2 cube. Right. So if I have done, because here we are talking about cube root of 8. So if I do the cubing on both sides, like 1 by cube on both sides, so then this will become x power 1 by 3, and here 1 by 3, and here 2. Right, which means here what I am getting here, I am getting 1 power 1 by 3 here. So whenever we are having 1 power 1 by 3, then it's easy for us to have the cube root of unity, because just now we have discussed that. So let's simply do that. So here we are having 8, so we have to find the cube root of 8. So 8 power 1 by 3. So this can be written as, so 2 cube whole power 1 by 3. So I am writing here 2 cube into 1 whole power 1 by 3. So now how it will become? So it will become 2 into 1 power 1 by 3. So if we have 1 power 1 by 3, so what are those roots here? So those are nothing but 1 omega and omega square here. So now I can directly write my roots here are nothing but 2, 2 omega and 2 omega square. So these three roots will be my cube root of 8. Right. So similarly, let's try and find the cube root of 27. So what are the cube roots of 27? So please let me know the answer. So quickly let me know what's the answer for this. So whenever we are talking about cube root of this, so because just now we have derived for our 1 power 1 by 3, then it will be directly, if we have 1 power 1 by 3, in that place we can directly represent omega 1 and omega square. So instead of in the place of 1 power 1 by 3, here we are having 2 into 1 power 1 by 3. So 2 must be multiplied here. So similarly, let's tell me the answer for cube root of 27 here in the same typical manner. Come on guys, quickly let me know the answer. Did anyone got the answer for this? Second one, cube root of 27. Sudan and Ridhishri. So 27, we have to find the cube root of it. So it will be 27 power 1 by 3. So how can we write this here? 27 how can we rewrite 27? I'll just give one more minute so that you can give me the answer. So what's the answer? What happened, guys? Still solving? Okay, I'll just solve it here. So 27 whole power 1 by 3 can be written as, so 3 cube into 1 whole power 1 by 3. So this will become 3 into 1 power 1 by 3. So which is nothing but 3 omega and 3 omega square. So similarly, if I have minus 27, so minus 27 in the sense that will be coming only when we have minus 3, because here we are talking about cube root. So minus 27 whole power 1 by 3. So this will be minus 3 whole cube into 1 power 1 by 3. Sorry, this will be getting cancelled if I do the cube. So yeah, Ridishi given 3. Okay. So minus 3 omega and minus 3 omega square. Because here we are talking about cube root. So for that we will be having 3 solutions. Right. If it is fourth root, then it will be 4 solutions. So the 3 solutions here are, first one it will be 2 omega and 2 omega square. For the second one it will be 3 omega and 3 omega square. And for the third one it will be minus 3 omega and minus 3 omega square. Right. So these are our simple and easy examples here which are related to our cube root of unity. So let's solve a question here. So which is related to our cube root of unity. So here the value omega, so the symbol omega is nothing but cube root of unity, and you have to find the value of this typical expression which is given here. So quickly solve this and let me know what's the answer here. So just see the expression what they have given and remember the properties which we have seen. So what are the properties? So the first property is cube, omega cube is equal to 1, and the second property is omega can be written as 1 by omega square, or omega square can be written as 1 by omega. And our third property is sum of the roots, that is 1 plus omega square is equal to 0. So these are our properties of cube root of unity. So now we have to apply these properties of cube root of unity to solve this typical question here. So quickly try and solve this. So please quickly apply these properties and solve this. So you can either start this question expression solving it by taking omega. In place of omega you can take omega square, or else in place of omega square you can start and taking omega and you can solve it. So how we are starting? Did anyone got the answer? So there are two options. You can replace in place of omega square with omega or else omega with omega square. So any of the method you can follow. So you can use in the numerator or denominator. So accordingly you can substitute. Okay. So here the thing is according to so a plus b omega plus c omega square by b plus it's divided by b plus c omega plus a omega square plus a plus b omega plus c omega square divided by c plus a omega plus b omega square. So here we know what is omega. So omega is nothing but our one of the root of cube root of unity. Right. So where omega is equal to -1 plus I root 3 by 2. So this is our omega. And for our cube roots of unity, so for this you have to apply these properties of cube roots of unity which we have seen in the earlier. So using that you have to simplify this and you have to find the what is exactly the value of this. So these are the properties related to cube root of unity. So do you guys need some more time to solve it? Please let me know. You guys need some more time to solve this question? If yes, I'll just give you some more time. If not, we can just solve this. So what happened, guys? What's going on? Do you guys need still more time? Okay, I'll just give you a few more minutes. So it's very basic application of our properties. So once you just apply the property and you can simplify it. Yeah, sir, you will just wait for 2 minutes because Sidhan asked for time. So after that, we'll just solve this question. So here if you observe the numerator of the first term, here we are having a plus b omega plus c omega square and in the denominator b plus c omega plus a omega square. So in the numerator I doesn't have any omega coefficient to my a alphabet, but in the denominator I am having omega square. So accordingly what I'll do, I'll remind the numerator as it is and I'll try to replace the denominator. In place of omega square here, I'll write 1 by omega. Because here if I write 1 by omega, when I take LCM, my A term will be having only A, right? So only A instead of omega square. So let me do that. So B plus 3 omega plus A. In place of omega square, I'm using my property and substituting 1 by omega in my first term. So now how it will be in my term here. So after taking the LCM in the denominator, so it will become B omega plus C omega square plus A by omega. So this is my denominator. So in the same way, if I observe my second term here, that is A B omega C omega square C plus A omega plus B omega square. So here I am having omega as my coefficient in the denominator, but in the numerator I am not having any coefficient for A. Right, so now what I'll do, I'll remain my numerator of the second term as it is, and again I'll be changing my coefficient of A in the denominator. So it will be C plus, in place of A I am going to write A by omega square, because omega can be written as 1 by omega square. So plus B omega square. Right, so let me take the LCM in the denominator. So B omega plus 3 omega square. So if I take LCM, this will become 3 omega C omega square plus A and plus B omega power 4. Right, in the denominator I'll be having omega square as it is. Right, so this question we have to solve based upon the equation, like given the expression, by comparing the numerator and denominator. So what are the coefficients of A, B and C? So based on that we have to apply our properties correspondingly. Right, so now if you observe the first term, it is A plus B omega plus C omega square. In the denominator also A plus B omega plus C omega square. So these two will get cancelled and I'll be having so 1 by omega, which is nothing but omega here. Right. So what about my second term here? So it is A plus B omega plus C omega square. But here A plus B omega power 4. So what is omega power 4? Omega power 4 can be written as omega cube into omega. And according to my property, omega cube is equal to 1. So my omega power 4 is nothing but equal to omega. So now for my second expression, so this omega power will be converted into omega, and now if you observe the expression again, it is A plus B omega plus E omega square. So these two terms will get cancelled and I will be remaining with 1 by omega square, which is nothing but omega square. So now after simplifying it, I am having my expression omega plus omega square. And again, according to our property, we are having 1 plus omega square is equal to 0. And in place of omega plus omega square, what we can write? So omega plus omega square. So this one will be coming to the right hand side, which is minus 1. So hence my value here will be equal to minus 1. Right, so the value of this given expression here is equal to minus 1. Right, so here the thing is we have to use our properties accordingly to solve the question here. Right, because here if you observe in the numerator we are having only A, whereas in the denominator I am having omega square. If I could able to eliminate this omega square as the coefficient, I can easily cancel my both numerator and the denominator expressions. So that's my first funda here to start the question. So that's why I have started with my A coefficients, and in place of omega square in the denominator, I have replaced that with 1 by omega. Same with the second expression also. So if I observe my numerator term, I am having only A, whereas in my denominator I am having omega. So I have replaced my omega with 1 by omega square so that I could able to cancel my both numerator and denominator terms. So in the end, I end up having my expression after the simplification is equal to omega plus omega square. Right, so according to our third property, that is 1 plus omega square will be equal to 0. Then correspondingly my value of omega plus omega square is equal to minus 1. So hence the value for this huge expression here is nothing but equal to minus 1 here. Right, I hope you guys understood this one. So did anyone had any doubt in this? Please let me know, guys, if anyone has any doubts in this typical question, which is related to our cube root of unity. What happened? Still anyone has any doubts, or else you guys are clear with this one? If you guys are clear, we can move on to our next one. What happened? No response. Did you guys clear with this one? So the answer, the value here will be equal to -1. Okay, I think you guys are clear with it. I hope you don't have any doubts. So let's move on to our next concept, that is nth root of unity. So in the previous one, what we have done with cube root of unity. Okay, clear. Okay. So cube root of unity. So now we are going to cover the nth root of unity. So for that, I have taken my complex number z, which is equal to 1 power 1 by n. So as we are writing for the nth, which means it's a generalized format, right? So that's why what I am going to do here is I am going to convert this my complex number in terms of polar representation. So here as it shows 1, which means what will be my argument, that is what will be my value here, that is 0 degrees. That means this one inside, which can be written as cos 0 degrees plus I sin 0 degrees whole power 1 by n. Right, so here cos 0 degrees plus I sin 0 degrees 1 by n, because cos 0 is 1 and sin 0 is 0, which is nothing but again equal to 1. So this one I have rewritten as cos 0 degrees plus I sin 0 degrees. So if I talk in terms of generalized form, so this can be again rewritten as cos 2m pi plus 0 degrees plus I sin 2m pi plus 0 degrees. So this whole power 1 by n. Because when we are having 2 m pi here, then which means our okay. So here we are having 2 m pi. So in place of 0, I can even write to be 2 m pi plus 0, because 2 m pi plus 0 degrees is nothing but again cos 0 degrees. Similarly, sine of 2 m pi plus 0 degrees is nothing but again 0 degrees. So instead of taking only the 0 degrees angle, in terms of general form, I have written that in terms of cos of 2 m pi plus 0 degrees plus I sin of 2 m pi plus 0 degrees. So as in 0 here, I can eliminate 0 here and I can write to be cos of 2 m pi plus I sin of 2 m pi here, and the whole power 1 by n is same. Right. So now if we are having cos theta plus I sin theta whole power 1 by n, so what we can write this according to our De Moivre's theorem. So the power which is present here, that will be coming as the coefficient of our argument here, which means this angle here, this will become, so I'll write it here. So this will become cos of 2 m pi by n plus I sin of 2 m pi by n. So this is according to our De Moivre's theorem, which we have learnt in our previous class itself. Right. So from where our exact angle starts here? So it starts from 0 degrees. right? So when we'll get 0 degrees here? By taking my m value is equal to 0. So if I start with my m value 1, then I'll be having directly 2 pi by n. But I'm already having 0 degrees here. So I have to get the start from 0 degrees. So when I exactly have 0, then my m value is equal to 0. Right. So my first root here will be at my m value equal to 0. Right. So then what about my second root? I'll be having my second root at m is equal to 1. And my third root when m is equal to 2. That means my m value is nothing but 0, 1, 2, 3 and so on until n, right? But here we are already included 0. So it will be until n minus 1. So when we talk about n, it will be starting from 1. But here our m is starting from 0. So we'll be having until m from 0 to n minus 1. Right. So let's write what are the roots here. So my first root here is nothing but when my m value is equal to 0. So when m is equal to 0, then what I'll be having directly my z is equal to 1. Then what about my second root? I'll be having my second root when m value is equal to 1. So let's substitute 1 here. So then my z will be equal to cos of 2 pi by n plus I sine of 2 pi by n. So this will be my second root. So let me write it as z1 here and let me write it as z2 here. Right. So this is my first root and this is my second root here. So my second, okay. Let me write it to be z only and here I'll be writing this will be z1 so that it will match with my m value so that we won't have any further confusions. Right. I think you guys are understood until this step. So if you're clear with this step, we'll just have the next steps now. So let me erase this part. So after simplifying, I end up having my z to be cos of 2 m pi by n plus I sine of 2 m pi by n. Right. So based upon my m values here, I'll be having my roots here. Right. So if my m value is equal to 0, what is my root? That is z is equal to 1. Then if my m value is equal to 1, then what about my root? This will be z equal to, so cos of 2 pi by n plus I sine of 2 pi by n. Right. So this z here can be represented according to our Euler's form. What this will be? So this can be represented as e power I, what is theta? 2 power 2 pi by n. Right. So here my second root, that is when my m value is equal to 1, is nothing but in short form e power I 2 pi by n, which is nothing but z equal to cos 2 pi by n plus I sine 2 pi by n. Similarly, let's see what happens if my m value equal to 2. So let me take at m value equal to 1 my z1 and at m value equal to 2 I'll be having z2. So this will be 2 in place of m. I am going to substitute 2. So this will become cos 4 pi by n plus I sine 4 pi by n. Right. So when m value is equal to 2, I'll be having my root here, that is cos 4 pi by n plus I sine 4 pi by n. So in terms of Euler's form, this is nothing but e power I 4 pi by n or not. So this is e power I 4 pi by n here. Right. So this is my second root, that is my third root when m value is equal to 1. So instead of that, I am going to take my e power I 2 pi by n. I am going to represent that with alpha. So how in cube root of unity we have represented the cube root with omega. Here in nth root of unity, we are going to represent this e power I 2 pi by n with alpha. And here when m value equal to, it is becoming twice. So this will be my alpha square. Similarly, if I take my m value equal to 3, this will become z3, that is cos 3 into 2, so 6 pi by n plus I sine 6 pi by n which is nothing but e power I 6 pi by n, which is equal to alpha cube. Right. So likewise, I'll be having my roots according to my m values. So my m values are starting from 0, 1, 2, 3 and so on until n minus 1. Similarly, what are my roots? When m equal to 0, I'll be having root 1. When m equal to 1, it will be alpha. Then next alpha square, alpha cube and so on until alpha power n minus 1. So these are my nth roots of unity. So if in general, if I asked about what are the cube roots of unity, so those are nothing but 1 omega and omega square. Similarly, if I ask the same question for nth root of unity, so which are nothing but 1 alpha, alpha square, alpha cube and so on until alpha power n minus 1, where my alpha is equal to e power I 2 pi by n. So this is the comparison. So this is for my nth root of unity. So the same way we have even done for our cube root of unity. What are the roots? 1 omega and omega square. So what is my omega equal to? That is equal to minus 1 plus I root 3 by 2. So in the same way how we have done for our cube root of unity, here we have done for the nth root of unity here. And what are the roots for the nth root of unity? So those are nothing but 1 alpha, alpha square, alpha cube and so on until alpha power n minus 1, where my alpha is always equal to e power I 2 pi by n. Right. So these are my nth root of unity here. So in some questions, they might have represent these roots with respect to like 1 alpha, alpha power 2, alpha subscript 3. So in some cases, they will be representing like this. So this doesn't mean any different thing. So this will be same as our here 1 and alpha the same. Alpha 2 is nothing but alpha square. Alpha 3 is nothing but alpha cube and so on alpha power n minus 2. So in some questions they will be representing in this manner also. But in and overall, so these are my nth roots of unity here, and my alpha here is nothing but equal to e power I 2 pi by n. Right. So as here we are having these are my nth roots of unity. So as I mentioned here, we are going to have some properties. Right. So before getting into the properties, so let's just have a quick overview. So what are our nth roots of unity here? Alpha, alpha square, alpha cube and so on, alpha power minus n. So these are my roots here, where alpha is equal to e power I 2 pi by n. So this root will be coming when my m value is equal to 1. This will be coming m equal to 1 and so on until m equal to n minus 1. And what is my z here? It is cos 2m pi by n plus I sin 2m pi by n. Right. So in place of this equation, you can substitute the m values and accordingly we end up having our nth root of unity here. So the major thing here is, so these are my nth roots of unity: 1 alpha, alpha square, alpha cube until alpha power n minus 1, where my alpha is equal to e power I 2 pi by n. Right. So this is all about our nth roots of unity. So now I hope you guys are clear with it. So now let's get into the properties which are related to our nth root of unity here. So as we are talking about nth root of unity, our properties here are nothing but related to nth root of unity itself. So there are nothing but sum of the roots and the other is nothing but product of the roots. So let's see what will be the sum of the roots. So first let's see what are our nth roots of unity. So those are nothing but 1 alpha, alpha square and so on, alpha power n minus 1. So as I mentioned, in some cases we even write this to be, so in general format what we'll write, so we even going to write this to be 1 alpha, alpha subscript 2, alpha subscript 3 and so on, alpha n minus 1. So there is no difference, both are actually the same. So now what we are going to find? Sum of the roots. That means 1 plus alpha 1, so we are going to take the sum of the roots, that is 1 plus alpha 1 plus alpha 2 plus alpha 3 until alpha n minus 1. So what are these? So these are nothing but 1 plus alpha square plus alpha cube plus until alpha power n minus 1. So if you observe, it's in the geometric progression. Right, so it is in the geometric progression. So sum of n terms here. So what is the formula for sum of n terms? So it will be a into a minus r power n by 1 minus r. Right, so what is the a here? So 1 into a minus r here. So what is my r here? Alpha. So alpha power n by 1 minus r, that means 1 minus alpha. So according to my nth root of unity, what is my alpha equal to? So my alpha here will be equal to e power I 2 pi by n. So let's substitute our alpha value here. So this will be becoming into 1 minus e power I 2 pi by n whole power n divided by 1 minus e power I 2 pi by n here. So here this n and this n will get cancelled, right? And I'll be having 1 minus e power I 2 pi by 1 minus e power I 2 pi by n. So here I am having only in terms of theta, like there is no n. So now I can convert this. So this will become 1 minus. So cos 2 pi plus I sine 2 pi. Right. And in the denominator 1 minus e power I 2 pi by n. So now in the numerator, as we doesn't have any generalized term like n or m, we can directly find the value of this here. Right. So cos 2 pi plus I sin 2 pi. So what is the value of cos 2 pi? So cos 2 pi value is 1. And what about sin 2 pi value? Sin 2 pi value is 0. Which means this entire time going to be converted into 1 minus. So 1 plus 0. And in the denominator I am having the same term e power I 2 pi by n. So here in the numerator I will be having 1 minus 1. And denominator 1 minus e power I by 2 pi n. Which is 1 minus 1 0 by 1 minus e power I 2 pi by 1. So in the numerator, if we have 0, whatever the denominator it will be, the final answer will be equal to 0 itself. Which means from here what we can predict? So here we can directly say that the sum of the roots of this nth root of unity is nothing but equal to 0. Right, because we know that what are the roots 1 alpha, alpha square until alpha power n minus 1. And we already know what is this alpha equals to. So here alpha equals to e power I 2 pi by n. Right, so we know that here it's in the geometric progression and sum of n terms in geometric progression is nothing but the formula a into 1 minus r power n by 1 minus r, where r is the common ratio and a is my first term here. So that formula we have applied here, and after simplifying this, we end up having the sum of the roots here will be equal to 0. Right, so this is the first property here, that is sum of the roots, which is equal to 0 here. So let's get into the second property of nth roots of unity. So the second property is nothing but product of the roots. So let's do this one. So what are the roots again? 1 alpha, alpha square until alpha power n minus 1. So here what we are going to do? We are going to do the product of this, which means this will be equal to 1. So anything into 1, it will be 1 only. So alpha, alpha square, alpha cube until alpha power n minus 1 will get cancelled. And here this n will get cancelled. And I am going to have this to be e power I into pi into n minus 1. So I hope you guys are clear until now. So please let me know if you have any doubts. So what happened for this product of the roots? We have taken as the base is common. We have taken the base common and added up the powers here, which end up having in sum of n terms, that is n minus 1 terms. So we applied the formula n into n plus 1 by 2, where we end up having, after simplifying it further, it is equal to e power I into pi n minus 1. So let's write in terms of our polar form. So this will be cos pi into n minus 1 plus I sine pi into n minus 1. So this will be my product of the roots so far. So now based upon my n values, what is the exact value here I am going to have for my product of the roots. Right. So let me erase this part. So what is my product so far? So this is product equal to cos pi minus pi into n minus 1 plus I sine into pi n minus 1, sine of pi into n minus 1. Right. So we can have the n values, either it can be even or odd. So we'll be having two cases here. So what will be the value when n is odd and what will be the value when n is even? Right. So if I have n odd, so let it be 1. So it will be 0 here. So what is the value of cos 0? So cos 0 is 1 and sin 0 here 0, which means when I have my n value is odd, I will be having this entire product to be equal to 1. So let's take for even, let it be n equal to 2. So if I take n equal to 2, here it will be 2 minus 1, that is 1. So cos pi, right? So cos pi plus sin pi. So cos pi value is minus 1 and sin pi is 0, which means if my n value is even, then my product of the roots is equal to minus 1. Right. So for the second property here, we are having two cases based upon the n value. So if the n value is odd, then my product of the roots is equal to 1. And if my n value is even, then my product of the roots is equal to minus 1. Right. So these are the two properties here. That is, what will be my sum of the roots? Sum of the roots will be always 0 for the nth root of unity, whether my n value is even or odd. Whereas my product of the roots will be varying based upon my n value, whether it's even or odd. So my product will be equal to 1 if n equal to odd, that is equal to 1. And if my n is equal to even, then I will be having my product to be minus 1. Right, so these are the two properties for the nth root of unity, that is sum of the roots as well as the product of the roots here. Right, so let's solve a question which is related to our nth root of unity. So here comes the question. So here you have to find the value of 1 minus alpha 1 into 1 minus alpha 2 and so on until 1 minus alpha n minus 1, where n imaginary roots of unity. So this is a JEE level question. So you can just spend 2 minutes by reading the question and try to understand this, and then I'll just explain you how to solve this question. So this is a clear JEE mains level question. So JEE level question. So because here we are going to apply our quadratic equations concept, as well as here we are going to apply our nth roots of unity concept also. So here we have to find the value of 1 minus alpha 1 into 1 minus alpha 2 and so on, 1 minus alpha n minus 1, where my alpha 1, alpha 2 and so on, alpha n minus 1 are roots of the cube root of unity, nth root of unity, which means even 1 will be there here, isn't it? So if these are my nth roots of unity, 1, alpha 2 and so on, alpha n minus 1, so these are my nth roots of unity of complex number z. Right. So if, for example, I am having a quadratic equation x square minus 1 is equal to 0. Right. So how I will be factorizing this? So this x square minus 1 will be written as x plus 1 into x minus 1. Yes or no? Correct, right? So where, what are my roots here? So my roots are x equal to 1, x equal to minus 1. Which means if I have my roots, I can express that in terms of factors, which will be equal to my equation. Right, so here what is my equation? That is correspondingly, this is x square minus 1. So if I compare this, that is nothing but my complex number z. And what are my roots here? So my roots here are 1, alpha 2 and so on, alpha n minus 1. So these roots, so this is x power n because we are having n roots here. Right. So this is my quadratic equation, like here it's a quadratic equation, so nth term it will be z power n. So now this z power n can be expressed in terms of the factors, that is product of the factors. Yes or no? Correct, right? So now I am going to have here, so in general I will be having nth root, in the sense it will be 1 power 1 by n is equal to z. So now let me erase this. So I hope you understood the concept behind the quadratic format here. So I have taken z is equal to 1 power 1 by n. So I can simplify this, z power n is equal to 1, which implies z power n minus 1 is equal to 0. So this is my equation here. So for the previous, in terms of quadratic, I have taken x square minus 1 equal to 0. So here this is equal to z power n minus 1 in terms of our complex one here. Right. So now what are the roots? So what happened? You are having a voice problem, Riddhi? Shall I continue? So what happened, Riddhi? Can I continue, guys? Or do you have any questions? Please let me know. Shall I continue this one? Riddhi, Sudhan, are you having any questions related to this? Come on, guys, quickly let me know. Okay, let's just continue. Okay. So here, this is our nth root of complex number. So after solving it, what will be my equation here? So that is z power n minus 1 equal to 0. Right. So here, I'll just compare with in terms of our quadratic form so that it is easy for you to understand. So here's x square minus 1 is equal to 0. So how will we be factorizing this? So this will be factorized to be x plus 1 and into x minus 1. That means here -1 and +1 are my roots. So using my roots, I can write my factors where my product of the factors will be equal to my equation here. Right, so here in this complex term, what are my roots here? So my roots are 1, alpha. Okay, registry already given the answer. Are you talking about the answer for this? So it should not be equal to 0, because here it comes some limits formula format that you guys didn't know yet. So I'm just giving it a idea how you can get questions related to this nth root of unity in your JEE level. So just have a look here. So first part and all, it will be easy for you to understand. So this z power n minus 1, this can be written as product of its factors. So that is nothing but 1 alpha, alpha square, and so on, alpha power n minus 1. So here what this can be written as? So this can be written as z minus 1 into z minus alpha 1 into z minus alpha 2, and so on, z minus alpha n minus 1. Right, so if I observe this right hand side of my equation and the given question, so it is 1 minus alpha 1, which means this term is not existed here. So I'll just bring this z minus 1 to the other side, which will be z power n minus 1 by z minus 1, which is equal to z minus alpha 1 into z minus alpha 2, and so on until z minus alpha n minus 1. So now if I compare my given question and the right hand side of my equation here, so in place of z, I am having 1 here. Right, so I have to substitute 1 in place of z. Right, but can we substitute this directly? So we cannot directly substitute it. So that's why here comes our limits formula. So that is, I am just applying limit z tends to 1 and limit z tends to 1. So you have to understand, you have to clear until this step, and the next limit step will be, you'll be seeing when we are doing questions related to limits, but I'll just explain you how we'll be getting the answer. So let limit z here equal tends to 1. So in place of z, we'll be directly substituting 1 here. Right. So now what it will become? If I directly substitute 1, what will happen to my denominator here of my left hand side? 1 minus 1, it will be 0. So which cannot be possible. So this will be differentiated and solved in further, but that you will be learning when you are doing the chapter of differentiation as well as limits and continuity. So far you must be clear until the step, that is z power n minus 1 by z minus 1 is equal to z minus alpha 1 into z minus alpha 2, and so on until z minus alpha n minus 1. So you have to be clear until this step, and the remaining, so I'm not going to do it right now, because I just want to give you a view how you actually get the questions related to the nth roots of unity, and the complete thing will be again seeing when we do the chapter of limits and continuity. So there you can, so until this step, if you are clear with it, then you can solve it easily by applying the limits concept. So I hope you get this concept of nth roots of unity as well as the sum of the roots and product of the roots. So this is one of the typical type of questions we can get mostly from this nth root of unity for our JEE conditions. So that's all for today, guys. So in our next session, we are going to continue the rest of our topics of complex number. So that's all for today. So if you still have any questions and things related to our today's session, you can feel free to ask me. Right. So, okay. So if you are clear with it, we can just wind up our session for today. Okay. So that's